Let's wait for some time, then we will start the class. So we start the class and let's wait for 5 more minutes and others will join, then we will start. Thank you. Some Harita, do you want to say something? You raised your hand. If you have any question, you please ask it. Then let's start the class. Any question from any doubt from the previous lectures? Am I audible or not? No one is responding, so just I am asking. I'm audible, right? So please ask questions from the previous lectures because this is the doubt clearing class. I think it will be beneficial. Or you can post question in that message section also. So if you have no question, then I think I should start the class. So one first question, I thought something that today we'll discuss about. Mm, This type of question usually comes in that competitive exams. So let me share my screen. Am I audible, right? No one is telling anything.
Yes,
Yes,
ma'am,
ma'am,
audible.
audible.
Okay, no question from your side, right? If you guys are following the lectures, then I think you should have some questions or doubts. In other tutorial classes, you people are attending or any other persons are attending? Okay, no answer. Okay. Okay, the question is, let me write the question first. The you sir discussed about oxyhemocyanin and hemoerythrin. I'm asking you people. Okay, if sir not, then I will discuss. The question is okay. We have to find the coordination geometry. The question came like that. They are asking for the coordination geometry. Coordination number and the binding of oxygen. And okay, this color. So, you people know the answer. Can anyone tell me what is the structure of the oxyhemocyanin? Okay, no answer then. I think first we should know the structure, then we'll solve one by one. First, let's draw the structure. If people doesn't have any doubt, I'm asking actually. These are the histidine coordinations. Three histidines are coordinated. Histidines are coordinated. The nitrogen copper this nitrogen and copper bond is there. Three histidines are there this side and this side three histidines are there. Okay, so for this is that sorry, this is the oxygenated form. Now copper was histidine. Three histidines were there. Means sorry, coordinated. So what is the coordination number around the copper? Can anyone tell me this answer? The question they asked.
5 coordinated.
Yeah, it's five coordinated. Right. Coordination number is five. So one question was solved. So the this is the starting material copper one. Okay, they asked for this complex. Sorry. Okay. The next what was the next question? The binding mode of oxygen. So what is the binding mode of oxygen here? Do you people know about eta 1, eta 2? Anyone?
No, ma'am.
Okay. So here you see, okay, here you see the two atoms are there. With copper, two atoms are getting connected. It will be eta 2 coordination. So for another copper, what will be the case?
Eta 2.
Yeah, that will be eta 2. Like eta 2, you understood, no? Oxygen is a molecule and two oxygen atoms are connected to the copper. So it's eta 2. This eta term, the 2 is coming from two atoms are attached. Correct? As it is a another thing, as it is a bridging complex, so the coordination mode will be eta 2, eta 2. Understood? Hmm?
Yes, ma'am.
Any doubt? You can ask me actually.
Ma'am, can you explain that hydrolysis of urea to give carbon, water, and that mechanism?
Hydrolysis of urea. Mm,
Yes, ma'am.
okay. This had discussed. Can you just start discussed in the class
Yes, during nitrogen fixation.
during nitrogen fixation? Yeah. So nitrogen fixation, urea to water. You just ask another. You just tell me nitrogen fixation, urea to.
I think like I didn't understand that mechanism part, like where urea got converted to ammonia and some water molecule. That the enzyme involved in that reaction was urea.
Okay, do you have that slide with you?
No, no, actually I'm traveling right now.
Okay, okay. Water hydrolysis happens, guys. But ammonia thing, what you are telling? Okay, I think ammonia transformation. That's why you were just asking. Nitrogenous means ammonia transformation, no?
Yeah, atmospheric nitrogen to ammonia.
Atmospheric nitrogen to ammonia. Atmospheric nitrogen to ammonia transformation is different. This you are asking. In terms of hydrogen, sorry, nitrogenous enzyme.
Yeah, like how does that enzyme work?
Okay, so um, should I share the structure of the enzyme?
Sure, give the catalytic cycle, but that cycle will have a different.
Okay, 1 second. There are a lot of mechanisms that I think I should okay, nitrogen reduction. Let me share the mechanism first. Can you see this? Huh? Hello?
Yes.
Yeah, okay. So here you are seeing two pathways are there, alternating and the distal, right? So it's written here, alternating pathway and the distal pathway. Can you able to follow it or not? Hello?
Yes, ma'am. I'm looking at it.
Okay, so in the alternating pathway, what happens that that H comes means hydrogen or proton or actually proton 6 protons and 6 electron means 6 hydrogen radical, right?
Yeah, yeah.
So what is happening here? To transfer nitrogen to ammonia, 6 H dot are needed. Hydrogen radicals are needed, right? Right or not?
Yes.
Yes. So first, what is happening? First, in the intermediate, you can see that N and H. So there, one H dot is getting attached. Okay, in the
Yeah.
distal nitrogen atom. So, which is common for that alternating and distal both pathways. Can you able to see it? N and H intermediate.
Yeah, the first part.
First part. So now it has two options that hydrogen radical can attach to the distal nitrogen or that proximal nitrogen. Okay, means that where the nitrogen was getting attached to hydrogen, same nitrogen or different nitrogen it can attach, right? NH, if the H atom attached to different nitrogen center, then it will form NH, that alternating second intermediate.
Yes, yes.
So in the distal pathway, if the two H dot attached with the same nitrogen, so it will form that NH2 intermediate in the distal third intermediate, right? Got it right?
Can you repeat that?
So if two hydrogen atom attached with the same nitrogen, then it will form NH2 intermediate in the distal third intermediate.
Yes, yes,
Okay, these are two possibilities, right?
yes,
Right
yes.
now. So that now another when another NH is attached will attack. So it will follow. It can follow two pathways. It can form NN first in alternating pathway from NH to NH2, right? H dot attached with the one nitrogen because it is free now. Na? Why this below nitrogen? Can you able to follow that below nitrogen is not hydrogen radical is not attaching with it because it's close to ligand and it has to face some bulkiness of that ligand environment.
That
But
M is the ligand.
metal complex.
Yeah, fine.
So when another H atom is comes, then it will and that nitrogen that away from the metal is now free means sterically less crowded that this nitrogen.
That will attach with HCl.
Yeah, that is accessible, right?
Yeah, yeah, got it.
Yeah, that is accessible now. For that, NH2 intermediate is forming. Hmm. So when now we are going in the alternate pathway. Now when another H dot it come, it forms that NH2 structure intermediate, right? Because it wants to form the
Now
symmetric
there
structure.
is now
Yeah,
despite bulkiness, it will attach there extra hydrogen.
yeah, because it doesn't have any other option because it wants to follow some symmetric structure. If you know that NH2 molecule is very stable, hydrogen. Hydrogen
Yeah,
molecule
okay.
is stable, so it always will try to prefer to make something that is more stable. So hydrogen it will form hydrogen coordinated metal complex. It will form the intermediate
Yes.
because it doesn't have any other option. That's why because stability is the main factor. Then so stability wise it will be much more stable. So in some reaction we get hydrogen also a product byproduct because it if some reaction hydrogen is the byproduct na, then we have to think that the reaction process the this alternating pattern, right?
Yeah, yeah, yeah,
Because in distal there is no hydrogen formation. Okay, so when another H dot comes, it attaches with that nitrogen which is away from the metal complex. Hmm?
yeah, ammonia.
Ammonia is forming, then another MNH2 bound complex is forming. It's if the metal nitrogen bond is now weak enough to liberate the ammonia, then it will liberate the ammonia and will give that the complex without that metal nitrogen bond, right?
Yes.
Anything you didn't understand, you please tell me. Any word or anything. Why it is happening, you got it or not?
Yes, yes.
Forming now. You can ask this question that MNH2 NH3 is a species that intermediate. It will liberate ammonia in the last step in such a condition that metal NH2 bond has metal N bond has to be weak enough, right? Otherwise it will not get. So
Yes,
that
yes.
so the choice of proper ligand and how you will make the catalyst, that is also important. You these things you have to take in mind. Bulkiness, if bulkiness is more, then you can't go to alternate pathway because that another hydrogen will not come to bulkiness means too much bulkiness, it will not come in the that nitrogen close to hydrogen metal complex, so hydrogen will not form. These things you have to taken care of. And another thing, uh, metal complex has to be bulky. Why I am telling? But the extent of bulkiness you have to regulate actually. Why it has to be bulky? Otherwise, nitrogen is a gas, right? So if wants to coordinate, so it has you think some cavity, you have to make some cavity where nitrogen will sit. So if we increase the bulkiness around the metal, then it will face some cavity like that. Or if it is not bulky enough, then it can go and come like that. You got it?
Yes, ma'am.
If you're not getting it, please tell me.
In the distal part, ammonia is released at an adjustment.
Yeah, in the now I will explain in the distal path. In distal path, what is happening? It's ammonia is getting released and you are getting metal nitride bond. So in all complexes, metal means metal catalyst, it doesn't happen. It depends on the ligand what you are using and the metal also. If here, can you tell me what is the change of oxidation state when it is forming metal nitride of the metal?
Sorry, ma'am.
From the first metal nitrogen complex and metal nitride complex, what is the oxidation state change of the metal? Are you able to follow or not? Or what I am asking you?
Oxidation seen between what?
Nitride is forming, na? Nitride is N3 minus. So metal will be in metal nitrogen complex. If we consider metal is 0, then when it will transfer to metal nitride, oxidation state will be transferred from 0 to 3.
Yes, ma'am.
That you understood or not?
Yes, ma'am. 0 to plus.
So in all complex it can't able to show this transformation where that it can have many oxidation state, means many accessible oxidation state, just like molybdenum you can take molybdenum, rhenium, that plus 4 and plus 6, these are the stable oxidation state. So if we start from metal 1 oxidation state, means from metal nitrogen, then if we come to the metal nitride, it will be 4 plus 4 oxidation state, right?
Yes.
So in plus 4 oxidation state, molybdenum is stable. So that's why it wants to go from, it will follow the distal pathway, not the alternative pathway. Before
Okay.
monitoring anything, we have to taken care of the metal ligand. These things we have to optimize actually. Then we can choose which pathway will be followed. And
Yes, ma'am.
another thing is we have to calculate the, actually I previous class I discussed about that feasibility of the reaction by the calculation of Gibbs free energy change of that particular reaction. So if the Gibbs free energy change for the particular reaction is negative, then reaction is thermodynamically favorable. Thermodynamic, I discussed these things previous class. You were there, right, that time.
Yes, ma'am.
So if we can we have to first think about the thermodynamics, then we can control the kinetics by changing the ligand around the metal.
Yes, ma'am.
Okay. So when the complex form a metal nitride, then it will take another H dot. It will form that MH species. Then again 2 H dot it takes, it forms MnH3 species. Then it liberates the ammonia and we are getting back the metal complex. You understood this?
Yes,
Then
ma'am.
I will say another mechanism is there that that is not here in this paper. It's not there. So here you have no doubt, right?
No, ma'am.
If you have doubt, you can ask me actually. No doubt, right? Okay. Okay. So another mechanism is there. What happens there? So in that mechanism, some one complex is there. Some molybdenum complex is there, or means I'm just taking from paper. So there, some ligand environment is there in it, and it's forming like that bridging complex. Here, Ln. This is also Ln ligand and iodine. So in presence of nitrogen, it forms this kind of bridging complex. That the starting okay, then it homolytically cleave here and it will form. So this is the another mechanism. It happens automatically. This is not the alternating, this is not distal, but it happens automatically. Then successive three equivalent of H dot is getting transferred and you are getting ammonia. Right?
Yes, ma'am.
So okay, I will share that one thing. I will share that paper with you. Mm, this is the paper. If you want to know more, you can read this paper. Mm, this is the paper. Here, first species is NN cleavage is
Ma'am,
taking
it's not
place.
visible.
It's not visible, right? Okay, okay, so
It is.
is it visible now?
Yes, ma'am.
Yeah, so this type of molybdenum nitrate complex are there and it automatically cleave that NN bond and forms this metal nitride thing. Yeah, I will share this to you. Copy. If you want to know more, you just read this paper, you will get better understanding. I shared it in the chat section. You please go through this. If you not get, you many things you will not get, but the main thing that I wanted to highlight, this is the different mechanism from 3 to 2 transformation, right? Hello.
Yeah.
Yeah. Do you have any other question?
The question was about urease themselves.
Sorry. It.
The question that I initially tried to ask you was about urease.
Oh, urease. Okay. Okay.
Yeah,
Okay.
hydrolysis of urea. That how does that?
Okay. 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 Exactly. So, I think I should share this thing. It's visible, right? So, what is happening? This is general mechanism. So, in presence of water, it's getting hydrolysis. So, minus This is the intermediate. Then it's release one equivalent of water and it forms O minus, right? One equivalent of water and it's formed like that. Then again it will release. So in case of proton is if water it will take from here on if this you will remove. So here what we are getting carbon dioxide will be liberated. NH2 minus is there, so this proton source is there. So it will form NH3 plus carbon dioxide. In solution phase, what you can see that it will be transferred to bicarbonate CO3 minus plus NH4 plus. Yeah. Now,
Ma'am, I was asking that urea enzyme where it contains nickel center, that enzyme activity.
nothing of that continuous side with you, then I think it will be helpful for me to one by one explain. Okay, otherwise I need to, okay, I have to share, I think. 1 minute. This one, right?
It's the third lecture.
This you were asking, right? Hello?
Yes, ma'am, that with the two nickel centers. That, uh,
Hello?
am I audible?
Hello?
Ma'am, I'm speaking.
Okay, you're speaking. This is the catalytic cycle. So first, this you were asking, right?
Yes, ma'am.
So here what happens? First, that coordination happens. Means from, okay. Hmm. First, what you are seeing from this is the active site of the catalyst. Now, to attach the substrate molecule, some backend coordination site is required, right? So, here you can see the three water molecules are liberating and giving the backend coordination site around the nickel to coordinate the substrate, right?
Yes.
And so, what the next step, what is happening? So, now that it's also having some nitrogen having lone pair, right? So here you can see the distal histidines are there. So it will form this hydrogen. These things are not important, as this is the it will form some hydrogen bonding interaction, and here this hydrogen and this nitrogen, this is also hydrogen bonding interaction, this is also hydrogen bonding interaction, and here you can see that this NH2 it's having lone pair, it's giving to another nickel center because it's now coordinatively unsaturated because one water molecule leaves, right?
So the NH2 of attached group will coordinate with second nickel.
Yeah, second nickel center.
Yeah, okay.
right? Only coordination happens, and this is a neutral reagent, so no change in that oxidation state. Okay,
Okay then.
so here you can see that it's having the possibility of hydrogen bonding with that. These are the protein chains, so these things are important for stabilization only. The main part is here, means this till this now. Others are the stabilization. Then what happens? Then nucleophilic attack happens. So what happens? This is the OH minus, right? So it will attack this carbon. It's just like that only.
So the carbonyl carbon.
Yeah, carbonate. It's like that only. And it's forming O minus, and it's attached with this nickel center, right?
Yes, ma'am.
Hmm? So what in the next step is happening? Next step is happening the proton transfer step. Here you can see that the proton is getting transferred from here to here. Here is hmm. So it's forming NH3 plus. Actually, what happens where okay, why it's transferring that you can explain in another way also. When it's attaching with this, so means this transformation. If you are looking for, hmm, so what is happening here? So when it's getting attached, so now this proton is becomes more acidic. So it wants to transfer NH2 plus and it forms NH3 plus. If anything
Yes.
is because it is nucleophilic carbon, no, so it's attached, so it become more acidic, so it's transferred here and it's formed this intermediate NH3. So in the next step what is happening is a similar thing, means NH3, this NH3, this oxygen is getting attached, here you can see, and this ammonia, because this is a positively charged species, it will live like that and it will form NH3, right? If it is form NH3, then this bond will go back and it will form C double bond O. And as it is the negatively charged, it will form this thing. And in place of here, they showed that in place of water, it's taking one proton and forming ammonium.
Yes.
So when now the these things go out of the system, now again the how you can do the regeneration of the catalyst, adding this is the active site structure now. So two water has to be coordinated, so they are providing three water molecule, for one for hydrolysis of ammonia and another three are for the this coordination. You got it now, why they used for one water. This NH3 after liberation, it will take one proton and form NH4 plus, and another three will go for the regeneration of this catalyst.
Yes, ma'am. The mechanism what sir gave was not this much clear. Like the substituents were not clearly mentioned.
That's why I told you if you can share the mechanism, then it will be better for you. Because I have discussed only in my way only. You have that, can you share that thing? Hmm? Hello.
Hello, ma'am. Wait, I'll try.
if you just share, you just bring it, otherwise I can't able to see na. So how can I explain? If I think he already explained this thing only.
Yeah, like he told that, but the thing is, in the diagram, the subsequents were not mentioned. It was put at like dotted line was given.
Okay, that
Now
mechanism
I am
only.
able to understand
Okay,
by
now
looking
you
at his.
understood, right? You understand now, you
Now if
understood.
now if I see the mechanism, I can understand.
Okay, 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 I think I will share that thing then also with you people. Here the mechanism is completely clear. If you can, if you want to know more, then you can read this thing, read this paper. Yeah, I sent the papers in that chat box. You please take it from there. If you're not getting anything from there, you please let me know. I think now it's clear. It's clear, right?
Yes, ma'am. Now I am here.
Okay, okay, okay. Do you have any other question?
No, ma'am.
You have no question, right?
No.
Hmm. Others having any question? Others having any question? Should we discuss that I will start it from, or if you have no question, then what I will discuss?
Ma'am,
Yes,
there
sir.
was another thing.
There was another.
Doubt.
Yeah, yeah, you asked me. Hmm.
Ma'am, that redox stability of water.
Okay. Yeah. Oxygen to water transformation.
Yes, ma'am.
That you were asking. Yeah. Okay, you didn't understand that thing. Yeah. That you are asking.
Yes, ma'am. That there they calculate EMF and they did that pH ring, the graph and all they did.
EMF, actually,
EMF, not EMF.
in the SARS video lecture, right? Can you
Yes,
recall
yes,
what
ma'am.
he explained? Means what regarding
There,
what thing?
there he explained about redox stability of water. There he told about over voltage, over potential.
Okay, by changing the potential P dependence, I think he is talking about, right?
Yes, yes, ma'am.
Okay, previous class actually I discussed this thing. I think if you follow it, you can able to share, right? Sorry, oh, sorry, I have to share now. So what is happening here? Says that at
Yes,
E0,
ma'am.
at pH 0, 1.234 pixels. This is what the SH pH. So how we can write this? the 4 electron. So 4 is 2 square by H plus equal 4, and oxygen activity is pressure of oxygen that we are this and this one molar and this is 1 atm. So now what you can derive that, sorry, but now you can see that 1 by H plus to the power 4, right? This you know.
Yes, ma'am. We'll get
Hmm. So
1.23
yes,
volt.
yeah. So it will be plus log H plus to the power 4. So 4 will cancel. 4 log H plus. So now if we want to change it in terms of pK, then pH, sorry, minus log H plus pK, so pH. So here the thing is, if we change the pH, then this will also change. I think that's what you want to mention. At pH 0 only this term means that I previously mentioned versus at pH 0. At pH 0 only this value will get. This value will nullify. This value will go only E0. You will be equals to E0. If you change the pH, then it will also, the reduction potential there is a dependency between that pH and the reduction potential. Did you understand it? This you are asking, right?
Yes, ma'am. Like finally, after doing this, only copper and iron were considered to be reduced at active metals, right?
Copper and
Like
iron.
because the reduction potential lies in that range.
Hmm. Finally, we have
So
to
that is the
check
conclusion.
LCD. That's okay. So for the things, the particular reaction that in previous class also I discussed, that another way is first to see the reduction potential. Means we have to check that while whose reduction potential is high, that particular species will be reduced, and which reduction lesser than that, that will be oxidized. So right, so in another concept you can calculate by from the del g 0, del g gives free energy change from the reaction. Del g 0 equals to minus nf e0, na, n e0 is the from the reduction potential change of that particular reaction. In that way also you can, I think you didn't understand. So I was in the previous class I already discussed this thing. In that way also you can explain. So what the thing I am to say, let's consider a species A plus B equals to A plus B minus. So, so it's oxidizing and it's reducing. So the reduction, how we have to write plus electron B minus. For A thing, what is happening? A plus, in terms of reduction potential, I am writing A, but I have to reverse. This is equation 1, this is equation 2. But for getting equation 3, what we have to do? Equation 1 minus equation 2, right? We will get equation 3. So, if so for equation 1, we are considering that del G0, we will get something. And now this one, del G0 1 and del G0 2. So, uh, del G01 minus del G02. Sorry, this is 0 into 0 into 1 1. So if it is positive means E0 is greater. If E0 is greater means it's having more reduction potential. So this reaction will be favorable. Reaction 1. Then reaction 2. If to get the reaction 3, so this will be the for the total reaction, this will be the reduction potential change. Sorry. So if this is positive, if when it will be positive, when E01 will be greater than E02, means E01 transformation reduction potential is more higher. Then it will be positive. Then del G0 will be minus NFE. It will be negative. Means that we can tell that reaction is thermodynamically favorable. In the reduction put means two things are same things. That we are getting the same result. If the reduction potential is high, then this transformation is be favorable because it wants to reduce B wants to reduce to B minus. Then in this way also from the this will be positive, del G will be negative. In this way also you can tell that reaction will be thermodynamically favorable. Did you get it? Hmm? Hello?
Yes, ma'am, got it.
Do you have any other question?
No, ma'am.
Okay, I think we two are there. Okay, let's see. Okay, so if you people have no question, and then we'll meet in the next class. That doubt you today asked, that is clear, right, Akshay?
Yes, ma'am, clear.
Yeah. So you please
Thank you,
read
ma'am.
read the papers I shared with you people. So that for that particular question you read for that mechanism part. If you're not getting, you can get back to me in the next class also. Okay. I think today we'll end the class. If you don't people have any doubt.
No, ma'am, no doubts.
Okay. Thank you. Thank you for being here. Okay. We'll meet in the next
Thank
class.
you.